सब्सक्राइब करना, शेयर करना। भाई आज हमारा स्टडी स्टार्ट है, आप लोग को पता है। बस आप लोगों को ध्यान रखना चाहिए और हमारी वीडियोस पर, और वीडियो को लाइक करना, ओके, और चैनल को सब्सक्राइब भी करना, शेयर करना, और बगैर बेल आइकन को स्किप नहीं करना। भाई आप लोग आ जाओ हमारी वीडियो की तरह हो कि मैं अपना वीडियो को इधर से स्टार्ट कर दे सकता हूँ, आप लोग भी देखें, ओके। और चैनल को सपोर्ट करें ज़रूर, ओके, और लाइक और सब्सक्राइब भी करें और शेयर भी करें, ओके। भाई वीडियो की तरह आ जाते हो, आप लोग देखो और सीख लो, ज़िंदगी बदलो, जियो और ज़िंदगी बदलो। वीडियो भाई कौन सा है हमारा, ये हमारा बुक वगैरह है, आप लोग देखते हैं। भाई मोस्ट इम्पोर्टेंट टॉपिक चल रही है आजकल, तो आप लोगों को ध्यान रखें, ओके, और वीडियो को लाइक करके चैनल को हमारा सब्सक्राइब भी करें, ओके। व्हाट इज द इलेक्ट्रिक पोटेंशियल, उस खबर आदि चे इलेक्ट्रिक पोटेंशियल हवाले सर चे इलेक्ट्रिक पोटेंशियल विलिकी गिसता से आदि चे इलेक्ट्रिक पोटेंशियल विलिकी गिसता वो जवा टॉपिक लन सवा बता दे चे व्हाट इज दी मतलब electric potential the which have amount of work done to also carrying a unit charge. Your unit charge means from the charge away sara. Whenever you sum the work done uku select the charge money the your point to the another point upon it. Move your seat matlab displace home to accelerator. Or your unit charge or your haskes ma charge. The kitam is called electric potential. What's like no. Let us consider a positive plus charge place oppositely charged parallel plates. A charge experiences a force in the electric field. If the charge is allowed to move freely in the electric field, it will move from plate to A to N. Plate B acquire kinetic energy. Now, on the other hand, external force is required to move the charge against the electric field. In order to move the charge with uniform velocity from B to A, and external forces must be applied which is equal and opposite to charge E is shown. This force will maintain the equilibrium by preventing the charges from acceleration while moving from A to B. Let WBA be the work done by the force in carrying a positive charge from point B to A, point A, without disturbing the equilibrium state of the charges. The change in potential energy delta U of charges is defined to be the equal to the work done by the force is carrying the charge from point 1 to the other again the electric field. और जो work done की the B न to A था, उधे दरमियान the बड़ी चीज चल गई है। The which B the work done की by the force is carrying जो positive charge बानी from B to A point without disturbing X the disturbing one show. This which is the equilibrium state of the charge, the equilibrium probably state of the charges. The change in potential energy charge defined is equal to work done by the force is carrying the charge from one point to the other against the electric field. Electric field के दरन अलग के तंग इस काल से जो work done उसो B to A, where U A and U B represent the potential energy at point A and B. The U A the U B means represent the potential energy to the point B to A तक where if this charge is released from point A, it will move from A to B and will gain equivalent amount of kinetic energy. Potential difference between 2 points is the work done in moving a unit positive charge from one point to another. Keeping the charges is electrostatic equilibrium. It implies that will equation implies key where VA and VB are the electric potential at point A and B, respectively the defining equation gave. The UA the potential energy the charge is there or the speed there. The potential energy the charge is there or the speed there. This is the equation from B to A. Now where delta V is potential difference. Delta V is potential difference between A and B, the A or the B terminal. Potential difference is the joule per coulomb, which is term is volt. Or potential difference means the joule per coulomb, or that term is a volt. Joule per coulomb work mechanical potential difference ratio, and it is represented by the volt. Then 1 volt The 1 joule divided by 1 coulomb is called so 1 volt. Kada ci mun jo 1 joule energy ra wadu divided by 1 coulomb charge bani. Taki no mun it's called the volt radi, or 1 volt. The 1 volt is potential difference between two points in electric field. If 1 joule of work done is moving 1 coulomb of charges from the one point to the other point, no other multiplies and some multiplies of volt. The 1 multi-volt multi-volt 10 minus 3 V 1 microvolt UV 10 minus 6 V microvolt nam kam di. The milli no micro 3 kam vi. Milli घंटे micro डेढ़ kam di. 1 kilovolt 10 3 V 1 megavolt da dinal vedi. 1 gigavolt da dinal vedi. No Fn amount of work done is required to move charge from one point to other within the potential difference between the two points is given. Kala ce musra amount of work done osho ce required to musra ce dum da charges ce mu be mu ko da yo point na tata bal point ta or potential difference talmiyan da kitam ga skal so issue da kitam ga skal wal issue to potential difference electric potential ha. Obviously, which is the electric potential at any point in the electric field equal to work done in bringing a unit positive charge from infinity to that point, keeping in it equilibrium. Now we will use the equation V is equal to W divided by Q. Electric potential energy and potential due to point charges. Now the question is what is the electric potential energy? Or better khabara bakiradi electric potential energy and potential due to point charges. Potential of point charges CV. Now like Earth, chimunga mas लगता है like के अर्थ मतलब अर्थ वास्तु like earth gravitational field every charges has electric field which it theoretically expand up to infinity. Consider a isolated charge fixed in space के दे. If a test charge चिकमदे is placed in infinity and the force on it due to charge plus is zero, if the test charge is in infinity which is moved toward plus q, is force of repulsion act on it. So work is required to be done to bring it to point A. Hence, when the test charge is at point A, it has some amount of electric potential energy. The closer the test charge to the charge plus Q, the higher will be the electric potential energy. The electric field does not remain constant but varies as the square of the distance from the charges. Now, the equation for electric field intensity it is 1 over 4 pi epsilon naught U divided by R square R. In order to keep E constant, the test charge is moved toward the infinitesimally small displacement. The work is done, Ushu. The negative signs chicken data in the above equation show E and delta R in an opposite direction. Now putting the value of E from equation in equation B here. देखिए the test charge is the प्रातिनिधिक हाँ. Net the test charge is the large distance RA from charge. We divide the distance between RA and B into infinitesimally small displacement so that the field intensity over each displacement remains constant. At the beginning of the first displacement, E varies in 1 over RA square, and at the end, E varies in 1 over R1 square, since the average 1 over R2 over each small displacement, 1 over R square, 1 over R. Therefore, one R is replaced by RA and another by R1. To calculate work done in this small displacement, we put 1 over R square, 1 over RA, 1 over R1, and delta R, RA minus R1. We get the electric potential at electric potential بخبرك بارك دي رجال أخبرك Electric potential starts your electric field intensity والأفريج charges من الغروب. Application the gas habarawa. The gas lana makte musra flux maximum minimum zero. بأين مكتو أين مكتو يا musra application of the work application of the electric field electrostatics application we have like a representation of electric field intensity, Coulomb law or properties of the charges. उस लग गया भी सके potential electric potential energy and potential due to point charges. Electric potential energy guru or potential due to the point charges terminal the guru. The point charges terminal the مثلا potential CV मतलब سمرة بي دي بارك من most important خبر روانة ده لو ده ما هو والسر هذا ما جدي example لغوي 4 point charges دي replaced you in the corner A, B, C, and D of a sphere A, B, C, D respectively. Find the potential at the center of the sphere if each side of the sphere is 1.5 millifarad. Solution. Show the square ABCD with charges. Place it its corner. The diagonals of the square intersect at point O. Clearly, point O is the center of the sphere. The distance of each charges from point O is 1 over 2, 1.5 square minus 9.5 square, 1.0606 meter. The potential at point O due to all charges is equal to the algebraic sum of the potential due to each charges potential at O due to all charges. Field and potential gradient. What is field and potential gradient? Field or potential gradient such a very field one it's a special meda you meda tamusu you field gradient no pai kisi chana hi akira single electric field is very difficult. Electric field से रिदावी यो very difficult. देर ज़्यादा घाट मुश्किल. Represent a diagram. तब हम क्या represent को बस कि पर diagram की both strength and direction can be indicated at every point in the electric. मुझे तो देर या strength चकम दे या ताकत मजबूत क्या और दे चकम दा direction दे ना मुझे indicate को पर यो every पर हर यो point वाले electric field is an alternative to field line diagram. Contour maps of the electric field can be drawn using equipotential lines. An equipotential line connects points in space where the potential of an electric field is the same is shown in figure. تيجي نجمع ده غير كم لاين داخلي the electric field ده كلاين ممكن سي ده ممكن equipotential lines around the positive and negative charge. The positive or negative charge مو per nucleus के वास्ते دي لगे जा पर مو gold lines داخلي ده lines equipotential line دي قال لي انت بقى electric field دي زيادة سنة مشكلة difficult ده مو قال لي represent by a lines ده مو per lines represent without طول ده خبطة دي انا مو لبيكشار بكار دي إذا line مثل كم line دي ده equipotential lines equipotential lines. For a point charge V U naught divided by 4 pi epsilon naught r. So all point at the same direction. 4 pi जगह मतलब pi ऊपर कीमत 3.14 दे E naught है वो r दे. So all the point in the same distance from the charges will have the same potential. The equipotential line for self-center on the charges. If there are two or more charges present, then the potential at any point is the sum of the potential due to each charge's potential is a scalar quantity. The vector quantity in the scalar the direction is opposite to a direction. This is called scalar quantity. However, potential can be either positive or negative. Potential negative की दिशा positive की दिशा when depending upon the sign of the charges. और दा सिर्फ डिपेंड की बस चार्ज पर साइन माने चे कम साइन मु चार्ज सरा करे नेगेटिव करे पॉजिटिव करे तो मु हाला. So the same basic idea is true on an equipotential map. The closer the line are together, the stronger the field at this point of an equipotential line are close together. कल जब मुझे equipotential line योबर सर समझाते रहने दी को close को, लेकिन तब मुझे पता लगी जिससे strong electric field. और कल जब मुझे line मतलब सो the electric field potential must be changing by a large amount of small distance or other, and there must be a large force acting. The exact relationship can easily derived for the field of a point charges if a test charge is moved small distance from point A to B. Work done on the test charge, force acting